first off, we have Usha Rengaraju. And Usha is an AI consultant and a corporate trainer. And she is the world's first woman triple Kaggle Grandmaster. So if you have done any data science stuff, you most likely have been to Kaggle. It's this data science hub, and maybe you have even seen her handle TensorGirl in some of the posts or data sets or competition. She's ranked as the top 10 woman data scientist by Analytics Insight magazine for 2021, top 10 data scientists in India for the year 2020 by Analytics India, and ranked as the top 105 AI leaders and influencers by 3AI magazine. So an amazing person, and she's also really fun to talk to. She's passionate about neurodiversity and bringing together neuroscience and AI, and she has put together a Neuro AI Symposium and Neurodiversity India Summit. And today, she's here to talk about AI for neurodiversity. Please welcome to the stage, Usha.
Good morning, everyone. Am I audible?
No.
Yes.
Yeah.
Yeah. Thank you so much for being here so early in the morning. And before I start, I would like to thank Grete and the entire PyCon Estonia volunteers and the team for inviting me from India. And so today's talk, I'm very passionate about today's talk. It's AI for neurodiversity. I organized Neuro AI Symposium back in 2019 in India, which was the first ever research symposium in the intersection of neuroscience and the neurodiversity. And I also put together Neurodiversity India Summit, which you can check it out online. It was continuously for 3 years. It's the first ever neurodiversity summit in India. So today we'll be talking about some of the use cases in the intersection of neurodiversity and AI. And so yeah, she has given a good introduction about me and some of the other open source contributions I have contributed to Keras Hub. How many of you have used Keras Hub here? Yeah, so I've contributed to Keras Hub, and I've also received TensorFlow Community Spotlight Award back in 2023. And TensorFlow is slowly coming down these days, and Keras is taking most of highlight right now. But back when TensorFlow was famous, I've been contributing a lot in research paper implementation, and I've also won Kaggle Research Spotlight Award for 2022. And I've also received a lot of awards from ML developer programs at Google. And you can follow me from my LinkedIn handle, and you can also follow my GitHub repository, where you'll have a lot of projects in the intersection of neurodiversity, which is Usha Reng. And this is my GitHub handle. And this is Kaggle ML Research Spotlight Award. And Google has also covered my community contributions in a YouTube video. You can watch this YouTube video during your break time. And so I've used a lot of pictures from a lot of online websites, and I've regenerated using ChatGPT. So before I start my talk, I would like to credit that. And there are a lot of demos which I've put together. So this will be a rough set of demos. I'll be like doing some talk, then showing some demo, talk, demo. I've sandwiched demos and talk parallelly. So this will be the rough set of demos which I have created POCs using Gemini. So yeah, if you are interested in having all the demos together, you can head on to that URL, and you will find all the demos in a single shot, where you can click and it will head on to the GitHub repository, where there will be a recorded video of playing the demo, and you'll also have the source code. So this is the place, just in case if you want to note down the URL. Yeah, so neurodiversity, back when I started my advocacy in neurodiversity in 2019, a lot of people haven't even heard the term in India. So before I start the talk, how many of you have heard of the term neurodiversity here? So yeah, neurodiversity is a widely misunderstood term. It's like, given all sorts of words, but there's no proper definition here. So there's an umbrella of conditions which comes under neurodiversity. So autism, ADHD, dyslexia, dyspraxia, and all of these conditions which you see here falls under the umbrella of neurodiversity. I specifically advocate for autism, especially on the higher end of the autism spectrum. So autism is a spectrum condition. There are people with varying abilities on the spectrum condition. So I focus on building tools for people on the higher end of the spectrum, how you can build assistive technology tools to help them live an independent lives. More on the lower end and the middle end of the spectrum requires a lot of clinical intervention. So AI alone cannot solve that problem. It requires a combination of clinical intervention and technological tools. So my focus has predominantly been on the higher end of the spectrum, building emotion regulation tools or emotion detection tools on how to identify neurodiverse conditions at an early stage. Yeah. So the first use case which I'm going to talk about is about the early diagnosis of neurodivergency. So I'll be focusing on autism because I'm an advocate for autism, but some of the use cases which I'm going to talk about applies for certain other conditions as well. So if you say take ADHD and autism, they are co-occurring conditions where there's overlap of symptoms across multiple neurodivergence conditions. So my focus will be on autism, but it can apply to the other neurodivergent conditions as well. So the first use case is about early detection of autism. Why this use case is very significant is there's a lot of research which suggests if autism can be diagnosed as early as 9 months to 12 months, there's a higher probability that the individuals can live an independent life throughout. Because your brain formation takes about, any adult, it takes about 25 years of age for their brain to fully develop. So if the diagnosis happens between 9 to 12 months, there's higher probability that the brain can rewire itself. A lot of early intervention techniques can be applied to the kids, and the kids, the brain can rewire itself, and there's a lot of possibility the kid can, there's only probability and possibility the kid can live an independent life. So that's why early diagnosis is very, very crucial. So early diagnosis can be done through a combination of techniques. It can be done through MRI. There's a lot of research which says it can be done through EEG techniques. There's a lot of research which says it can be done through multimodal approaches, using videos of kids playing, using videos of kids responding to certain questions. So there's a combination of techniques which can be applied for early detection of autism. The first technique which I'll be focusing on, MRI scans. So ABIDE is a data set which we have autism brain imaging data exchange. This is a data set which is open source and which is available, and this has been put together by neurologists across the globe, and this is an open source data set, so this can be picked up by anybody across in the crowd for the research if you are interested in this area. So the general pipeline is taking of features like you can use general. So one thing is ABIDE is available as an unlabeled data set, and there's a pre-processed version which is applied at after 2 years. There's a pre-processed version also available. So but the first version of ABIDE which came out was totally an unlabeled data set. So whenever you're dealing with unlabeled data set, so you can use any automated segmentation or parcellation tool to extract all features. Once you have extracted all the features from MRI images, then you can top it up with any of the machine learning classifier, and it's a classification, becomes a classification pipeline where you extract features and feed it to a classification algorithm. Classification algorithm, you can use your traditional machine learning algorithms like random forest classifier, or you can use your deep learning MLP, perceptron and stuff. But if it's going to be an unlabeled data set, then you definitely require a parcellation tool. So the first version of ABIDE which got released was an unlabeled data set. So this is a recommended pipeline for the initial version of the data set. And there are other standard techniques like FreeSurfer, FSL, ants, and all these are techniques, especially if the MRI images are unlabeled. And if you're going to have a labeled data set, later on after 1.5 years to 2 years, there's a pre-processed label version of Abide which got released. If you have a labeled data set, then you can use traditional deep learning segmentation based techniques like the UNet or the transformer variants, and all of these segmentation techniques can be used directly on it instead of having a two-way pipeline. So in addition to using this is a very complex problem. Detecting autism at an early stage cannot be done just by using MRI images. You require a multitude of data. You require MRI images, then you require a video input of eye tracking of the autistic kids. You require a video input of them responding to certain questions and diagnostics questions by the clinicians. And then you also require certain feedback from the caregiver. So it has to be a multitude of input which goes into the model. Just using MRI scans, it's not possible to give a very accurate model or a very accurate detection tool. So you require a multitude of tools. And there are some startups in India which are quite successful in putting together early detection of autism tool. Recently, there's one startup which got selected in Google for Startups Accelerator. It's called AI Gnosis. It's a startup based out of western part of India. They've been successful in putting together a tool for early detection of autism. And there's also another technology like Purple Files Technologies Limited, again based out of India. They've been successful in building a tool for the early detection. So there's a lot of startups who are doing very active work in this space. So again, early detection of autism is very, very crucial, because if you can diagnose it as early as 9 to 12 months when the brain development is still in the nascent stage, then there's a lot of early intervention techniques which can be given to the child, and the brain can rewire itself, and there's a possibility the child can live an independent life. So that's why this use case is very, very important. And the second use case, which I'm going to second, third, fourth use case will be connected with each other. It's about emotion detection in multiple modalities. Autistic individuals, especially on the higher end of the spectrum, they have difficulty. There's a lot of statistics which says a lot of individuals on the higher end of the spectrum, despite having double master's degree, despite having PhD, they still find it very difficult to stick to full-time jobs. And when we organized all these neurodiversity summit, we interacted with a lot of PhD candidates from a lot of premier institutions in India. And one of the common reasons which they are given to us is they find it very difficult. They find understanding social cues very difficult. They are unable to understand social cues. Just because they are not able to understand social cues, they are not able to communicate effectively. And that creates a trauma for them in the workplace. So that's one of the reasons. So if you can help build the tools which can help them identify emotions in multiple modalities, it could be text, it could be voice, it could be speech, and it could be facial emotion detection or social cues detection. Then when they can understand the emotions, they can communicate effectively, and that can help them have a better workplace environment, and they can communicate effectively their needs. One of the biggest reasons why they're not able to communicate effectively is they're not inability to understand social cues in the first place. So that's the use case, emotion detection and speech. So an autistic employee can speak to the manager, and the manager might express a lot of emotions in tonalities, but the employee may never understand the tonal differences. So anger can be communicated in a certain tone. Sadness can be communicated in a certain tone while in a call with an autistic employee. Employee might miss out on all these tonalities. So it's very important for them to understand the emotions in the voice. And the employer might send a very rude, angry email to an autistic employee filled with sarcasm and all the different, the employer could express different emotions through, in an email, but the autistic individual might miss out on different emotions, and they will take the direct communication out of the email, and they would miss out on different emotions present in the email as well. So that is why this use case is very important. And so we have a lot of data sets, benchmark data sets, RAG. So putting together a voice detection benchmark data set is extremely difficult. But thanks to the open source community, we have very good data set. I would personally recommend RAG. I have put together the use case in my GitHub repository involving RAG, but the other data sets, benchmark data sets, are equally good. So you can build a voice emotion classifier using these benchmark data sets, and we have a lot of off-the-shelf techniques to help us put together this pipeline. Either you can start with a classic ML engineering where you can take voice input can be converted to images. You can convert voice. You have a lot of libraries like Librosa and many other libraries which are voice processing libraries which can take voice input and convert it into MELS spectrograms or images. Once it's converted into images, then any feature engineering or feature processing techniques which you apply to image, you can apply to the same MELS spectrograms, extract all the features, and then put your any classical machine learning algorithm on top of it. So you can start with traditional pipeline, or you can go for supervised deep learning techniques which are specifically off-the-shelf models which are specifically built for voice emotion recognition. There's also like transformer-based architectures out there. These are all off-the-shelf models. So you have a benchmark data sets ready, and you also have off-the-shelf models ready for putting together the pipeline. What is missing is giving this as a consumable product to the autistic individuals. How would you convert this as a consumable product? Are you going to put this device in wearables, or is it going to be an eyewear or things? How can you convert this pipeline into a consumable product is what is missing. Again, emotion detection in text. This is going to be the very easiest pipeline. Before I start here, I'll show some of the demos which I had created. This is an Android app which I had created. This is a demo where any person, this can be created as a Chrome. This is an Android app demo. How was your day? The emotion in that text can be detected as a neutral emotion. So, it can be picking up the text like this, or you can also have a Chrome extension. So, Chrome extension might come in handy if you are going to have an email and you want to automatically pick. This is a Chrome extension. This is not good. So this is about AI emotion detection in text. So text emotion detection is very simpler pipeline. You can detect emotions using large language models. You can pick up any large language model, zero-shot classification. You can pass text and you can give a prompt, classify the emotion in the text, and you can get the answer out of it. I have used Gemini, but if you feel you're building an on-device application, you're building a mobile-based application and you don't want to use large language models, you can use smaller language models, because text classification problems, even very simpler models like Roberta, Deberta still gives you very good performance. So text emotion detection, we have Go Emotions data set from Google if you want to fine tune it for a certain language, because again all these data sets, most of them are available for English. If you are building a tool specifically for Estonian, then you might have to, I'm not sure if there is a emotion data set which is available in Estonian, so you might have to put together the data set. For English we have Go Emotions from Google. It classifies it as 27, it's a data set which has 27 different emotions. Again, for this to be truly accessible, we wanted it has to be multilingual. It has to be available in worldwide languages. be it Estonian or be it Indian languages. In India, for every state we have 2-3 languages, put together 100 plus languages. So it has to be available. For it to be truly inclusive and accessible, it has to be available in all languages. So for Estonian, if the data set is not available, then it's an open source project. Any of you can pick it up, create an emotion data set which can help autistic individuals classify emotions. Again, the third use case in emotion detection is we have seen voice modality, we have seen text modality, and the facial emotion detection. Facial emotion, I've just generalized it, but it involves a general body language as such. Autistic people have difficulty understanding body language and facial emotions. So, fortunately, we have a lot of data sets. I've just picked up one data set which is AffectNet. But it's a very comprehensive data set. The images are captured from individuals across the globe and not specific to any country. AffectNet has individuals across the globe and it has millions of images. Again, you have a lot of off-the-shelf models for building up a pipeline. If you want to build up a device and you have off-the-shelf model and you also have data set, maybe if you want to curate it for a specific country, you might have to create few data sets, maybe like less than 200, 300 images. You want to build a device which specifically works really well in Estonia. Then you can top it up with 200, 300 images captured across Estonia, and then you can do a little bit of fine tuning and it would work well. But we already have off-the-shelf data set and we have a lot of off-the-shelf models as well. Again, for this facial emotions, you can extract features and then build a machine learning model on top of it. So this would be the pipeline where you give an input as an image and you build a feature extractor. Feature extractor can be your deep learning or transformer based variant. Once you extract the features, then you can give it to your traditional neural network or a machine learning model, and then you can detect emotions. So these are some of the use cases which is mostly on emotion detection and early detection. Outside of this, there are some other interesting use cases which can help neurodivergent people as well. So one is adaptive learning. So different neurodivergent kids have a different pace of learning. So AI can really help, especially large language models can really help them create personalized content. And some of the kids, most of the kids are visual learners, so we have a lot of tools already out there where you give a prompt and which can create three-dimensional views of the concept or different animated views of the concept. So large language models and generative AI can help create personalized content. And the second thing is communication and AAC. Again, when you take autism, there is a specific group of individuals who are non-verbal autistic. So these individuals will have difficulty in communication. So I built a AAC tool. I built it using multiple technologies. The latest one I built is using Gemma 3. How many of you have used Gemma 3? Gemma 3N? So Gemma 3N is again multimodal. So this is assistive and augmentative tool for autistic or non-verbal autistic individuals. So this I created using the Keras version of Gemma 3. I was doing this for a Keras sprint. So it has very limited number of features and stuff. But right now Gemma 3N is multimodal. So you can build a very good variant of this. So I'll just play the demo. So non-verbal autistic kids, especially on the lower end of the spectrum, they have difficulty typing because most of them will have their hands shivering. So for them to type complete sentences is very difficult, but it's very easy for them to type. So that's where this is a very small demonstration of POC. Anyone here can pick up this use case, build a very good model using some white coding tools. So you show a set of words for them with images. So they are able to type what they want. I feel happy, and then you can convert and take the text as input, convert it into an audio, and then they can speak. So for them to type a complete sentence is very difficult, but they can type I, and if there's a screen which shows the next 50 possible words. Then they can tap and they can complete the sentence, and there can be a button which converts the text into audio. This could be a very good way for them to communicate. So this is an example for building an assistive and augmentative tool. I have built it using the Keras version of Gemma 3, which is very restrictive with minimal features. But the Gemma M3N, I think, is multimodal, so you can create a better version of this. So some of them also have a very specific routine which they follow. So there are tools like routine builders and other tools which can assist them in their day-to-day activities. So there are plenty of other use cases using generative AI. So I've just listed few of them here. And this is one such tool which exists in the market. So in addition to helping autistic kids identify emotions, early detection of autism, adaptive learning, assistive and augmentative tool, AI can also help train the kids to learn social and behavioral skills. So a lot of parents, when I was organizing all these Neurodiversity India Summit, I came in contact with a lot of parents in India who are parents of neurodivergent kids. Most of them, at least 90 to 95% of them, have given up their full-time careers to take care of their kids. And they said most of them are going through trauma because they are taking care of a neurodivergent kid is not easy at all. It involves a lot of trauma for the parents, so there should be a separate club for the parents, as well. So the reason why is they go through a lot of emotions. See, a parent can say, even if it's their own child, fifth time or 10th time when they repeat the same thing, they can get, very stressed out. They might yell at the kid and things like that. But a robot can repeat the same thing for 1,000 times and still not get stressed or still not get angry. But it can repeat the same thing for 1,000 times. So robots are found to be more effective in teaching autistic kids social and behavioral skills. And there's one such robot which is from Texas. It's called Milo. This is out there in the market even 3-4 years back. And this is being very effective in US for teaching the kids. It's priced at $5,000, but it's used by a lot of autistic kids, for training them to learn social and behavioral skills. And Google Glass, I think Google had temporarily stopped the Google Glass, and I think they have, during the Google I/O 2025, they've relaunched their Google Glass, and the Google Glass, the older version, didn't use AI. The newer version is powered by Gemini. I think this can be a game changer for autistic kids. Even the older version, which did not use any AI, was used by a lot of autistic kids for identifying emotions and things like that. But the newer version is powered by Gemini. This can be a truly game changer because if it's powered by an LLM single-handedly can identify or do all the emotion identification use cases. It can act as a very good assistant for autistic kids. So I think this tool is already out there in the market, relaunched again by Google. This can be a game changer. And if you are looking to build such use cases, most of the models and data sets are already available. So what is not available is a consumable tool which is very localized to that particular region. Because the language spoken in this country might be Estonian. In India, the place where I come, each and every state they speak a very different language. Right now, most of the data sets are there in English. So we require curated data set which is specific to that particular region. That is the future work and the future direction. So once you put that, it has to be converted into a consumable device. For example, Google Glass is a consumable device where the autistic kid can wear it, and the LLM powered device can help the kid identify, okay, the person in front of them is angry, so they could modulate the behavior based on how the person in front of them is behaving and all that. So it can help, identify emotions. If the person in front of the kid might speak in an anger tone, it can identify that emotion, that voice, and communicate to the kid so the kid can regulate the behavior. So the most important here is to take all this AI pipelines and convert it into a consumable device. And the consumable device should be friendly for neurodivergent. It's not just converting it to some product. It should be friendly for the kids to consume and get along well with the product as well. So that's the challenge. And with this, my presentation is done. And if there's any questions, you can ask.
Thank you. It was a really interesting talk. I quite enjoyed it. We do have a few questions here on Discord, so I'm gonna start with those and maybe see if there's any more from the audience. So, there's one question about how do the AI tools work with like the 9 to 12-month-old kids? And are the tools somehow connected to the standardized autism observation tests? Or how does it work with such young children?
So for 9 to 12 months kids, there's already a device out there in the market, which is one of the product startup is called AI Gnosis. So it is an early detection of autism device. So a 9-month-old kid will be subjected to a lot of video-based questionnaire. So based on the eye movement of the kid and how the kid responds to certain video questionnaire, all the input is recorded and it's fed to the model. And the model is able to predict up to 90% accurately whether the child is autistic or not. There's a couple of startups in India who have already launched the product, and one of them, AI Gnosis, is recently incubated by Google for startups as well. So they've already raised funding. So, from whatever the founder has put together a video about the startup, from whatever he says he uses a combination of MRI, social behavioral skill, and also feedback from the parents and caregiver, and the feedback from the clinician as well. So there's a lot of input which goes into the body. Okay. So a 9 to 12-month kid might not be able to operate with devices, but the use case which might be relevant for them is early detection of autism.
Okay. Now, there is a question specifically related to Estonia. So, how would you build a data set for Estonians when the facial expressions remains the same despite underlying emotions being vastly different?
Yeah, so there is one thing called micro-expressions. So this is one technique which I have been learning micro-expressions myself, because even I have difficulty understanding emotions. So I think it was like 8 years back I was training myself in this micro-expression data set, which is done by a psychiatrist who's based out of US. He has put together 40 years of research work. He's been training the military. Mostly when people from military or police deal with individuals, the individuals who are doing fraud or counterfeit, they are very good in concealing their emotions. They might be angry, but they are very good in showing other people that they are not angry. That's why they are very good in their counterfeit or fraud which they are committing. So they are very good in concealing emotions. But military and police individuals, or from the FBI or whatever, the police surveillance team of United States, they should be able to find the concealment as well. So that's when this psychiatrist who has done 40 years of research work, all his research is about, despite the individuals concealing their emotions, between the emotion being felt by them and their concealment, there's a tiny gap. There they express something called micro-expressions. So that micro-expressions is something which cannot be concealed. So somebody who's and there's also softwares to train people identify micro-expressions as well. So this is one technique where, despite the individual concealing the emotions and things like that, and this particular data set which was created by the psychiatrist, the data set has been collected from individuals across the globe, and it's a very lengthy research period of 40 years. They had spent extensively going to every country and collecting data sets from different kinds of people. So there's a very exhaustive data set. But again, if you want to and there are, I've not mentioned in my slides, but there are specific models which has been created, especially facial emotion detection models, which are very good. There's a state-of-the-art model which has been created to work on micro-expressions. So there's already people who have released state-of-the-art models which are very good in identifying micro-expressions. So these are expressions which between the time the individual actually feels emotions and before he could conceal it, or before he could express it, there's a tiny gap. So these are models which can detect these micro expressions itself. So I think that can help in a way, and again, if there is no benchmark data set available specific, even these benchmark data sets may not specifically work well with Estonia, because people of Estonia might have certain very specific features or attributes in expressing emotions. For that, what you should do is, the best way to collect data set is go to a university. University students will have a lot of bandwidth to volunteer for such activities. You can get a lot of university student volunteers. Go around collecting the data set. It is going to take you about 3 to 4 months collecting the data set, but if you can even put together about 300, 400 images, that's still good. We have models which will work very well when fine-tuned on very limited number of images as well. But the only way you can do it is somebody has to take an initiative and go around asking for university student volunteers to do it, because in India we get a lot of jobs done from university student volunteers because they have a lot of bandwidth. And so whenever I want data sets, I go to university, pick up some volunteers, we go around collect the data. It's going to take time, 3 to 4 months, but once you do that you can publish it as a research paper for everyone to use. So it can help you in your technical career as well, publishing a data. Once you curate a data set, that can be published as a research paper as well. So that will act very well for your career as well. So it's an open source work.
So I do hope to see some data sets from Estonia coming soon. Okay, there's a question about AI personalities. So in the context of AI tools like ChatGPT, we've seen like companies experiment with these personalities, and then they tend to roll some of them back, including ones that seem to connect to neurodiverse communication styles. So as AI becomes like more integrated into daily life, how should we think about designing these AI personalities so they support actually neurodiverse users without stereotyping or like excluding them?
Okay. So building tools which are very inclusive is a very important thing. A lot of organizations have already started the groundwork of it. So I think back in 2023, I was invited to Adobe to speak on AI for autism. So while I was giving the talk, I was very surprised. It was happening across the Adobe development centers across India. So many of them were joining online. So around 50 to 60% of the population who attended the session were all UX designers. So I asked them, this is an AI talk, and why 60% of them are UX designers? The product management head who organized that meetup told me, no, we are in Adobe, we have started like several years back, they have started the work of making all their products very inclusive. So if you build any product where there is UI elements which is too crowded, it might be very difficult for neurodivergent people. So, the spacing of UI elements has to be taken care of. So there's a lot about the UI and product look and feel of how you make it very much accessible to the individuals. That's a lot of research work. Again, this is very localized and very region specific, because there are a lot of things which might be very specific to the individuals in a certain region, may not tolerate certain colors, may not tolerate certain, placement of certain elements in a certain way. Again, this is very localized and region specific. So this requires a lot of research, testing it out on real neurodiverse people to get this right. And this is a very tricky part, and it's going to take a lot of effort, but there's definitely some kind of an action which has to happen, start in that direction. So I'm very happy to see a lot of organizations like Adobe, Google, many of them have specific research teams which works on how to make it very accessible and very inclusive to a wide range of audiences. So there's a lot of companies who have taken that initiative. Again, this has to happen globally at all levels and has to it has a very region-specific requirement as well. So it's a tricky thing. We have to start. That's the thing.
I guess, like in this inclusivity theme to connect it to, how can we account for the bias in this autism diagnostics data sets? Like there's even an example brought, like females tend to be diagnosed later in life, so the diagnostics criteria can be geared towards males. So like how do we avoid this bias to go into these models and tools of AI?
So one thing about biases, biases are whatever content we see out there is equivalent to what the perspectives of human beings right now what they have. So I cannot speak for Europe or US or other countries outside India because all my advocacy for neurodiversity has been predominantly in Indian region. And so one of the difficulties when I started advocacy for neurodiversity back in 2019 is there's a lot of stigma. This may not be relevant for an audience outside India because I don't know, each and every country will have different awareness level. At least in India, the awareness level is very, very bad, at least when I started advocacy in 2018, 2019, because of the stigma attached to the cause. There are a lot of people who are self-diagnosed as autistic, but they're feeling it very difficult to come out and say they're autistic, because if they say they're autistic, their employment opportunities will go away. They'll be looked at in a different way in the society and things like that. So a lot of individuals don't openly come out and say they're autistic because of the stigma which is attached to it. And girls, I think, the social conditioning and all that in India, I think the women are even more reluctant to come out and talk about their self-diagnosis and things like that. So bias may be the higher level problem. But to solve that higher level problem, it has to start from the groundwork. The groundwork has to be creating an awareness. Top 3 activities for autism advocacy in India will be awareness, awareness, awareness. First thing is creating as much awareness for people to at least come out and find a safe space to talk about their self-diagnosis or talk about whatever they're going through. That is more important. If the situation is so stigmatized that individuals are not even able to talk about, then the perspectives and everything will not change. So the society has to, whatever you see, the data sets out there, the content out there, it's all the perspective of human beings. And for that to change, I think it has to start from the ground level. There has to be more open spaces where people can come and talk about. I think the conditions, the awareness level might be slightly better in Europe and United States, I'm not aware. Maybe during the break you can tell me what kind of awareness levels you have with regards to neurodiversity in this region. But at least in India, the situation was bad in 2019. But when we first started the conference, but 2023, 2024, we started seeing a very good improvement where there's a lot of organizations started having neurodiversity employee resource group. This employee resource group is not just for neurodivergent individuals. There are many organizations like Adobe have neurodivergent parents group as well. So if they are a parent of a neurodivergent kid, for them also they go through extreme stress. So for them they had a separate employee resource group. So these are like good safe spaces for them to come and share things about. This will create good awareness, and then the perspectives of people will change, and then the bias, the higher level problem, the data sets and everything will automatically get changed. But for this, I think the lower level, ground level is very important.
Okay, let's see. We have more questions coming in, so this talk is very popular. I'm very happy about this. Okay, so there's actually a question about like this wearable hardware. I'm not sure how well you can answer this one, but like in your experience, what has been the best hardware format to avoid like sensory issues related to these autistic individuals?
Okay, so the best hardware in my understanding and in my interaction with neurodivergent kids, the best hardware might be an iPad. So because any other hardware, I'm not sure will sit well. Again, this has to be tested out, but it's just my perspective on the take is eyewear is very easy to wear, and for anything like social cues detection and emotion detection, I think the glass is placed in the right position to observe the person in front of them. So the glass can also have sensory device which can detect the voice and things like that. So, and the glass, if the person is sitting in front of the laptop and computer, the glass can also see the text in the email as well. So this is one hardware device which is positioned so well that it can detect emotions at multiple modalities. And for especially individuals on the higher end of the spectrum, there's a lot of candidates in India where we invited them to speak at Neurodiversity India Summit. They have like one of the premier institutions in India, like NCBS, National Center for Biological Studies. Most of them have PhD degrees, double master's degrees, but they're still finding it very difficult to understand and comprehend emotions. So for individuals, especially on the higher end of the spectrum, I think these assistive tools might go a long way in helping them live an independent life and understanding social cues and communications better so they can communicate effectively, maybe find full-time jobs, integrate well with a lot of other things. So in my perspective, I think the eyewear might work out well. It can be also like wearable mobile watches, or it can be a mobile phone. Certain things can be picked up by a mobile phone. So the sensors can be placed everywhere. Again, it depends on, this is a kind of thing which requires a lot of beta testing and testing with real world people to find out which might be the best thing. So I'm just sharing my perspective on it.
Yeah, thanks. Now, here's a question. So, it seems like part of your framework equates an autistic person's value with employability, so like the ability to hold down a full-time job, rather than with personal well-being or self-determined quality of life. So, I guess the question is like, why is this your framework more about like this employability, or did you just choose this like angle for today's topic?
I choose this topic because, see, I am an AI developer and I've worked with a lot of very good cutting edge projects in generative AI, so I could have easily picked up a topic in LLM safety or privacy and things like that. But this is a topic which I took because it will have a real impact. So if there are 200 people here, I am successful in creating some kind of an awareness at some level with this many audience in a different country. So some of you can get inspired, build some products or tools. There was one of, I think there was a conference called Everyday AI Bangalore, back in Bangalore, where I think it was in 2022 when I gave the talk. There was one attendee who was a master's student from UK who went back and did a thesis on AI for autism. So there is definitely some kind of an impact which can come by giving talk on this topic. And this is a topic where I have done personally groundwork. So I have organized Neuro AI, which is India's first research symposium, and I have organized Neurodiversity India Summit for several years. I have interacted, I have a lot of groundwork on this topic, and I have built a lot of POCs on AI for autism. And so I have also gone to several forums. So this is a topic which I can connect to deeply, and I believe there will be definitely some kind of an impact of some scale. So I chose this topic over other generative AI, but otherwise professionally you can go check out my LinkedIn profile. I'm a professional AI developer. I work in generative AI projects and I work in very, very interesting projects right now. And on weekends I also work as a professor at practice. It's a part-time role where on Saturdays I teach for the master's program in data science for various universities. I teach one subject per university, so I get to go to different universities and stuff. So on weekends I work as a professor at practice for AI, and so that's my full-time job. This is a topic which I can connect to deeply, and that's why I chose this topic.
Yeah. So, I mean, the question kind of, I feel like you already answered, but like what inspired to have started advocating and helping diagnosing people with neurodivergence?
So the reason why I started giving 2019 when I started this advocacy, I was initially experimenting with topics like Autism 101 because I want to destigmatize the way autism and neurodivergency is looked up in India. So in order to destigmatize that, I started with Autism 101 sessions. Back in 2018-2019, AI was picking up really well, the community space was doing really well. So when I did Autism 101 session, the audience turnout was almost like 10 people, 5 people, and all the 5 people who turned up were the parents of neurodivergent kids. So only somebody who was personally affected for this cause were turning up for the meetup, and the numbers were very less, 5 or 10. So then I changed the topic to AI for autism. There were a lot of people turning up for the meetup because back in 2018-2019, Whenever there's something AI, people would turn up. Irrespective, something AI in the topic, then people would turn up. So that helped me create an advocacy and form a community and, take this advocacy movement forward. So that's how it started. So, I use AI for a very good cause. And see, awareness is very important. Technological tools can be built and it can be consumed. But if there is a lot of suicidal deaths in India, especially with autistic individuals on the higher end of the spectrum because of the stigma and the way it is looked at. So you can give them all the cutting edge education, you can give them all the tools, but if the society is still not accepting them and not treating them really well, that can still not solve the problem. So technological advancements, building tools is all good, but awareness and acceptance will be the core of this work. So there should be sufficient awareness and there should be some kind of way where we can create an awareness on how to treat autistic individuals, how to treat neurodivergent individuals, what are do's and don'ts for them. So there should be some way of communicating this to a larger group of audience as well. So that will be the groundwork. And of course we are in a very good phase where we are in a cutting edge technological movement where there's a lot of tools which can be built by taking off-the-shelf models, off-the-shelf data sets, and we can put together a pipeline very easily, especially with generative AI and a lot of multimodal models coming up. If you see Gemma 3N is a multimodal model. There's a lot of open multimodal models which has come out, and there's a lot of models which can be used in devices as well. So if you take large language models, they're big, billions of parameters, but there are like smaller variants which are very good with devices also being released parallelly, and these smaller variants are also multimodal. So we are in very good cutting edge technological phase where we can build together good products by putting together all of this. But for all of that to happen, awareness has to be the first stage. So that's what I'm trying to communicate.
Yeah. Do we have any questions from the audience? Someone has something on their mind? Yeah, there's one there. Hello, can you hear me?
Yeah, thank you very much for your talk, and thank you for bringing this topic to the conference. One thing that I was thinking as you were speaking is that the examples that you gave, and this kind of builds on the couple of comments you just made in your last point and the question before last. In the examples that you gave, it seems to me that there is still very much the onus and the responsibility on autistic individuals fitting into kind of society no matter what. A lot of people, spend their life learning these techniques. A lot of people spend their life learning how to mask without even maybe knowing themselves or even being anywhere close to being self-diagnosed or diagnosed. I think keeping the responsibility and also the kind of pathologizing on the neurodivergent individuals potentially limits the amount of accessibility that we as a society can provide. And I was wondering if there are also some examples. So you gave the example of the manager, being angry and communicating in a way that didn't land. I almost thought in that moment maybe the use of AI tools for dealing and helping neurodiverse individuals actually live more, have a higher quality of life would be to tailor these tools to allistic people, and actually rather than having tools that help or somehow help process emotions from people that are not communicating properly, maybe rather, for example, the email scanner can be given to the manager, and then you can have some sort of tool telling you, hey, the emotion in your message is not very clear, the emotion that you're communicating is not very obvious, you might consider rephrasing your email before sending it, so that actually the pressure is on the people who are not being inclusive. And I think that way also accessibility is guaranteed not only for people who may or may not be diagnosed, may or may not be self-diagnosed, but also people, for example, who don't speak the language properly and can't pick up a nuance, or people that don't understand subtext for other reasons. That was just a sort of thought I had. And I was wondering if you had any examples for AI for accessibility, but for allyistic people, rather, to change their behavior?
Yeah, I think there are some of the companies who are already doing this neurodiverge, how to deal with neurodivergent employees. This kind of technique is given to all employees across the company. I got to know this was done for IBM in India. So IBM had training for all the product managers in the company across India, where they were training the product managers on the do's and don'ts on how to interact with neurodivergent people and how you can communicate with them and things like that. So whether AI tools can be used in helping the managers understand the neurodivergent people better, I haven't explored that side of things. I haven't explored that to comment on it, but that's a very good idea. So instead of asking neurodivergent people to understand all the emotions using tools, it can be the other way around as well. But I've not explored that side of things. And so, yeah, that's all I can comment on that topic.
Okay, thank you. It was a great talk, and thank you for bringing this to Estonia. I hope to see maybe some solutions targeted towards neurodivergent people coming from us as well, or if not solutions, at least maybe more people will take this into consideration when doing their own products. So this is a little feedback from us.
Yeah, thank you so much.
You can probably go and find Usha during the break that's coming soon, walking around here, and you can ask questions straight there. So we are now going on a small coffee break. We shall be back at around 11:50. So a 25-minute coffee break. And during the break, I do suggest you go into the demo area and see all of the booths out there. We have PyDrive, we have Playtech, we have Forgate, and we have Waybuilder. And actually, in the booths of PyDrive and Playtech, you have some fun games that